Today we will see why the welding is very difficult in case of aluminum material. First reason is its thermal conductivity. As we know from the Fourier's law of heat conduction, is heat transfer rate is equal to minus Ka delta T by del X. As the thermal conductivity is very high, heat transfer rate is also very high. If we suppose this is the work material of aluminum, if we provide the heat for the welding purpose, heat get easily dissipated to the surrounding due to its high thermal conductivity. So required amount of heat is not generated for welding purpose. So welding is poor in the case of aluminum. Second reason is its fluidity and viscosity. Suppose this is the curve of temperature versus percentage composition. If you look at the messy zone, it is very less, and from casting we know that the messy zone is inversely proportional to the fluidity. So due to the less messy zone, fluidity is very high in case of aluminum. So when heat is provided and whirlpool is developed over the surface, the molten metal easily gets out due to its high fluidity and low viscosity. So whirlpool will never develop due to this reason. So welding is very difficult in case of aluminum. Third reason is when heat is provided over the aluminum material, the surrounding air react with it and form aluminum oxide. Aluminum oxide is a ceramic, and ceramic is a very hard material, and of its melting point is around 2000 degrees centigrade, and thin layer of aluminum oxide will be at the outer surface of the aluminum. At the lower end, aluminum of melting point around 650 degrees centigrade. So this is the major difference between the melting point of aluminum oxide and aluminum. Due to we have to remove this aluminum oxide layer for the better welding. So for that we use DC welding. What we do in DC welding, we take first of all workpiece and electrode. We give the DC power supply. Negative polarity we kept on the workpiece and positive polarity on the electrode. The electron move from this for this, and due to reverse polarity, the 1/3 amount of heat will be generated at the workpiece. So this portion we get around 30% of heat, and at the electrode we get 70% of the heat. So as we get the amount of heat over here, the outside surface of the aluminum oxide get peel off due to this, and we get the inner surface of the aluminum, and we easily weld that material. So we generally use DC supply with reverse polarity. This is also known as cathodic cleaning, the oxide cleaning, another name. Thank you.